Hello everyone, welcome to the screencast videos for CHY 103 or General Chemistry. I'm Riyasad and I'm here to help you with the basics of chemistry. Buffer calculations are very similar to weak acids and base calculations. There are some things to keep in mind when doing buffer calculation. The first thing to keep in mind is that a buffer consists of a weak acid and its conjugate base. So we refer to the Henderson-Hasselbalch equation at all times to measure the change in pH when any extra acid or base is added. The Henderson-Hasselbalch equation is pH equal to pKa plus log of base over acid. Now, for a buffer to completely work, the pH when any acid or base is added should be equal to pKa plus minus 1, or it should be in the plus minus 1 range to be considered as a working buffer. Now that we're set, let us look into the example we're given and follow the Henderson-Hasselbalch equation and also follow the ice tables because we are already dealing with weak acids, and so we will have to use the ice table, and we can use this equation, the Henderson-Hasselbalch equation, to solve our question, which is a buffer question. To start off, we need to identify our weak acid and our conjugate base. The weak acid is always going to be the one with the extra H and a plus 1 charge. Or we don't have to write the entire weak acid down because it's time consuming, so we can denote our weak acid as the HA, or the A with the H attached to it. The base, on the other hand, or the conjugate base, is always going to be the one that lacks an H and a positive charge, and it's going to be A minus. So in this example, our HA is going to be HC3H5O2, and our base is going to be C3H5O2 minus. Now that we know our acid and base, we can form our ice table. So we have our Ka value, which is given to us, but we don't really need the Ka value because we are going to deal with Henderson-Hasselbalch equation afterwards, which deals with pKa. So our pKa is equal to negative log of Ka. So in this case, our pKa is going to be equal to negative log of 1 times 10 to the power of negative 5, which is equal to 5.00. Now that we have our weak acid, our conjugate base, and our pKa values, we can write our acid-base equation based on substance that is being added. So in this example, we have the addition of NaOH. So generally, if we add acid to our buffer, we will have to have our weak acid, or the HA, on the right side of the equation. So we will have something like A minus plus H3O plus would give us HA plus H2O. And this is to show that the acid or the product content at equilibrium is the one that increases. Similarly, if we have base being added to our buffer, which is the case for this example, we can write HA plus OH minus will give us A minus plus H2O. So since we are adding base in this case, we're going to choose this equation. Now, so far we know what our weak acid is, what our conjugate base is, and we know what the pKa is as well. We also figured out the reaction that we're going to use, which is HA plus OH minus will give us A minus and H2O. Now, we move on to the ice tables. So we have our initial conditions. We have 0.14 mole of H3, or the weak acid, in 1 liter. So our concentration is going to be the same. So it's going to be 0.14 initially. And then we also have 0.12 moles of the base. So 0.12 molar over here. Next, we have the changes. It's just going to be negative x over here, and then we're going to have a positive x on the right side of the equation. However, the value for x here is going to be the same as the value of the amount of moles of NaOH that was added after, which is 0.03 moles. So as a change, over here we have 0.03 moles of the base that's being added, or 0.03 molars because it's in 1 liter. It's added at this point, or at the change point. So as a result, the weak acid over here will be reduced, and the base amount will be increased at the same time. So basically our x value is equal to 0.03. So at equilibrium, we're going to end up with our weak acid concentration of 0.11 molars and our conjugate base concentration of 0.15 molar. Now that we have everything, we can plug everything into our Henderson-Hasselbalch equation. So we're going to have a pH, which is equal to our pKa plus log of the base over acid. We can rewrite this as equal to pKa plus log. Since our base is A minus, we can say that it's A minus, and then our acid is HA, we have HA. And now our pKa is 5, because we have it here, and log of A minus is going to be 0.15, our base, and our acid has a concentration of 0.11. And that'll give us a final pH of 5.13. Now, in order to verify whether this buffer is working, we can always check whether if it's in the plus minus 1 range. So our pKa was 5, and if we added 1, we would have a pKa of 6. If we subtracted 1, we would have a pKa of 4. Now 5.13 is between these numbers, so we are well within the range. So we can say that we are on the right track and our buffer is working, and this is the final pH that the example asked us to look for. Let us now look into a different example.